Well, good morning, everybody. Hi, I'm Joel Mosier, the Chief Scientist of the United States Space Force. Actually, the Director of Science, Technology, and Research is my actual title. And welcome to our Mission Capability Area session on digital engineering and advanced manufacturing. You know, digital engineering and computer modeling mean new weapons and platforms can be tested and demonstrated digitally before they ever fly. Such digital twins accelerate the weapons development process and shorten the learning curve. Advanced manufacturing takes those digital models, combines them with products from the science and technology world to create new advances in materials and processes, to reduce parts count, cut life cycle cost, and improve operational performance. And advanced manufacturing and digital technologies are really of critical strategic importance to the nation, and nowhere is that clearer than with our air and space forces, weapon systems. China is the world's largest manufacturing economy, and recently they announced their ambition to create 10,000 little giant enterprises that specialize in niche sector and 1,000 enterprises that are champions in single industry, as well as groups of leading companies. This announcement underscores China's strategic policy shift in the next 5 years to focus on breakthroughs in specific and critical sectors and supply chains. To compete in this area, the United States will need to continue to up our game in digital engineering and advanced manufacturing. So joining to me today to discuss all this are Wallace Lowry, Vice President of Strategy and Chief Transformation Officer of Raytheon Intelligence and Space Raytheon Technologies, Eric Hine, the Vice President for Defense and Advanced Development and Space Programs at Spirit AeroSystems, and Renee Passman, the Director of Integrated Systems, Lockheed Martin Advanced Development Systems, or the Skunk Works. So I'm going to ask each of the panelists to provide opening comments, and there will be a number to text for questions that I will moderate after this. But first up, I'd like to ask Wallace to give us a few remarks.
Thanks. I'm a little envious with all these BDUs around. If I knew that I could wear jeans and a shirt, I'd be much happier. But thanks for having me here. This is a really, this topic is extremely important to all of us. We're at a point in time across our industry and what we do for you, and that partnership and that alignment is critically important. So I know that some of the topics that we're going to talk about, it's getting a lot of dialogue, so I'm excited to see some of the questions. I run our strategy and transformation organization out of Raytheon Intelligence and Space. Prior to that, ran our space business and then our space and command and control business and our advanced programs organization. And we have gone through a lot of change, whether it's the implementation of DevSecOps or the fact that we have been working to implement digital manufacturing for some of our space systems. The interesting thing is we've largely been able to do that in the commercial market more so than the government side for some of the challenges that we've had whether it's mission assurance or there's a lot of unknowns that we've got to work our way through. But we have seen unbelievable advances in some of the things Joel just talked about relative to reducing cost, shortening schedules, and delivering capability that is much, much more flexible than anything we've built before. Also on the software side, for those on the Space Force side, we have a program called Forge, the processing architecture that we have been working with the Space Force in a very, very different way than any kind of software program we've ever developed before. And the speed at which we're integrating commercial technologies and developing those together is unmatched than anything we've ever done as a business. It's a little unsettling for us culturally in some cases, but it's also very, very exciting. So look forward to this, and thanks, Joel.
Thanks, Wallace. Eric.
All right, thanks, Wallace. My name's Eric Hine. I run Defense Advanced Development and Space Programs for Spirit AeroSystems. I'm bringing the supplier perspective to the panel today, so I'm going to use my time a little bit to educate everyone in my introduction here about who Spirit is and what we do. We're not a traditional defense contractor, so I had a couple of slides up here, but I'm just going to talk through essentially what it is that we do. So from Spirit standpoint, we're not Spirit Airlines, so a lot of people ask me that, but we're Spirit Aero Systems. So we build and design parts, everything from detailed parts all the way up through a complex, large modular airframe assemblies. And we do that. We've been traditionally commercial since 2005 at Spirit, and we're now doing a lot more in defense. We've had, you guys have all seen what's gone on with the COVID pandemic and the impact that's had on the single aisle market, in addition to some of the other single aisle issues that we faced. Spirit has a renewed focus on growing into defense, where we have a target of growing to 40% defense company in the future. And over the last few years, since we've been a defense company now for a few years, we've positioned ourselves as a premier Tier 1 aerostructures provider to our defense partners, so we can help them meet the ever-changing challenges that we have going forward. And those challenges are large part, we're going to meet those with digital engineering and advanced manufacturing approaches. And Spirit really looks at it in five major ways, and I think this is going to be consistent across how the supply base supports prime customers going forward. As a Tier 1, we are uniquely positioned. We have a large commercial company, a commercial base, where we can really prove out a lot of the advanced manufacturing processes as building blocks across our company. We're on every Boeing and Airbus commercial platform today, so it creates a huge proving ground for us. And we're also unique as a supplier in that we have to be agnostic to our customers. So I won't really sit up here and talk about tool sets, because we have to be able to work with all of them. And then for us, it's about really working in how we communicate with those tool sets, and then how we use that digital data to drive our production system. And so we're focused on really growing from a cost standpoint and driving benefits to our customers from a cost standpoint, integrating in IDEs, which is an integrated digital environment, providing industrialization surety. So we've scaled, and if you look at our track record, we've built at just about every rate out there. I mean, even in the Wichita plant, at one point in time, we were building 100 B-29s a month at one point in time, and obviously on 737s, and Airbus is building very high rates. But we also build at very low rates as well. And so leveraging that with digital process modeling and discrete event simulations that have a lot of data that actually back those results. From a quality standpoint, shifting quality to where we're actually designing the process, so what we get out of the build is actually the quality that we can get out of the process, and then using digital inspection to check that every bit along the way, so we don't end up with a bunch of issues when we get to final assembly. And then of course we're doing a lot more on performance, driving production performance with digital tools, and then accelerating change with things like full-size hole determinate assembly in our production lines. So that was a lot around what we're doing. We'll talk more details during the panel, but we think that's also something that translates to pretty much universally across the supply chain. Everyone's getting better at using these tools as a competitor in an environment against other suppliers. We have to continually get better at that, and agile at adopting new processes. And I guess just to take away kind of three things to remember about Spirit. We're a large aerostructures provider. We build everything at every rate and size, and we're growing in defense, and then we're helping our customers win and perform with digital engineering, advanced manufacturing tools. All right, thank you.
Thank you, Eric. Renee.
Awesome, thank you. So good morning, or afternoon, whatever time it is now. My name's Renee Passman. I'm the Director, Integrated Systems for the Skunk Works. That doesn't tell you what I do. That's a feature, not a bug, of my job title. But one of the things that I do is the Skunk Works, in its traditional role as the leading edge of Lockheed Martin, is taking a lot of the innovation that's happened across the breadth and depth of Lockheed's entire portfolio and pulling it all in and really seeing how we can accelerate, change the way we do business, empowered by digital engineering. For years, we've applied a lot of the latest technologies to a lot of our existing programs and made incremental gains in terms of cost and schedule and quality and time and all of those types of things. But we also see that when you bring it all together and start that way from the beginning, that you see even more opportunity. As one of our customers is fond of saying, in order for one thing to change, everything needs to change. And so in order to pull all of that together, the Skunk Works has been looking at a number of different ways to do that. And that includes everything from how we ourselves at Lockheed Martin do our work, how we interface with suppliers like Spirit, like Raytheon, like others, whether that is on the physical build of things made out of metal and composites, or whether that's on things made out of ones and zeros, and also, how those actually come together in a much more software-defined kind of world. And then also, one key part of it is how we interface with our customers, how we be more open, how we share more data, how we make sure that everyone's on the same page, and basically taking a lot of the technologies that, frankly, we've all gotten used to day in our personal lives. Your email tells your calendar where you're supposed to be, and everybody gets a meeting notice. And applying that to the defense domain space so that we can bring that all together in a way that significantly reduces the cost and the time required to get capabilities out to the field. And that includes the entire value stream, from whether looking at things in an early concept and how do we do things like digital RFPs, and how do you take all that information that we gather at the beginning of a program and drive it through the rest of the timeline. Design analysis is a huge one, and how does analysis play into test and validation and that key part of getting a product safely to out in the field with the capabilities it's supposed to have. And then also all the way through to sustainment, making sure that when something is out there, the men and women that use it and that maintain it have access to the data that they need in the times that they need it. And then also, and this is, I think, one of the key innovations in the last few years, tying that all back together so that you just get that much more agile and kind of proactive response to change rather than a very reactive, oh my gosh, something happened, what do I do about it? And really working that as an entire integrated system. And all of those things involve digital engineering. I think today we'll end up talking a lot about some of the advanced manufacturing elements of it. But whether it's DevOps, whether it's digital engineering for test or sustainment, making sure that it's all tied together and the data is getting in the hands of the right people at the right time to make the best possible decisions. That's part of what I look forward to answering questions about today.
Thank you, Renee. And for our audience, if you'd like to submit a question, there's the number on the screen. Please do, but I'll start it off with a couple of my own. In returning to you, Wallace, can you tell us a little bit more about what you think the most exciting developments in digital engineering and additive or advanced manufacturing are? And specifically, how are those going to change or improve our Air Force and Space Force weapon systems?
So Renee and Eric hit on a number of them. I think that it's, in any case for the Raytheon Corporation and our partners, where we have implemented some amount of what we would say digital engineering. And I always struggle with the term digital engineering because people check out. If you're not an engineer, you check out. And it touches all of us. It touches every function. It touches every part of the value chain, whether it's an operational value chain inside the business or a mission chain for our customers. And what we've found is that cross-functional partnership, that tight integration across the board, and that collaboration drives a lot of ambiguity and a lot of hidden technical debt, which has traditionally occurred as we've developed systems in the past. We've had a very air-gapped process of a lot of process where we build packages and documentation, and we hand them off to the next in a value stream, whether it's handing off a purchase order to a supplier, and there's a lot of things that are lost. I use the analogy that digital engineering is DevSecOps for hardware. DevSecOps really has helped us immensely in driving the tool chain, driving our processes, driving consistency, and driving a common architecture that enables some of the things that both Eric and Renee were just talking about. And it spans across whether it's the development of a part to a subsystem or a system, or being able to do system of systems architecting with that underlying data architecture and structure and the clear understanding of everything that occurred over the life traced back to some source of truth, be it the requirements in model-based systems engineering or wherever that start is. And we're just now beginning to see it. I think the biggest challenge we have is that we're all using different languages. We all break things up in different ways. We have all these different frameworks that we're working with. And so I think the opportunity for all of us as partners, as suppliers, as primes or whatever it might be, is to get down to the core of what it is we're trying to do, where is the value, and how is it that we're going to approach it, whether it's reference architecting, practices, and the languages and the data structures that we're using, because that will unlock the ability to drive integration, to drive more speed, to deliver capabilities and flexibility to address the challenges that you all, our customers, are facing every day. I'm not going to talk big about the advanced manufacturing piece. It's one that is also, we're just on the, I ran the space business prior. You talk about additive manufacturing, it's like voodoo for space. But we have seen huge benefits of that digital engineering chain as you get into really doing model-based work instructions and getting paper out of the equation and driving all of that traceability. We've seen 50% reductions in the integration of space telescopes, which we built a telescope for the Air Force called the Hypertemporal Instrument Imager. It took us 4 months to calibrate it. We're building commercial instruments for Digital Globe under a program called Red Legion, and we cut those in 50% with the first one just by using advanced manufacturing, digital techniques, and tools. And we're only at the beginning of being able to see some of those benefits.
Excellent. Thank you, Wallace. Eric, so the Department of the Air Force has called for application of digital engineering in the acquisition of all our weapon systems. And you talked about some of this before, particularly with it relates to supply chain, but from your perspective, where are we doing well, where are we doing poorly, and where should our focus be moving forward? And then as an adjunct, Wallace talked about the reduction in the integration and the development of new systems. How is this going to impact costs, not necessarily long term, but in the short term as we invest in tooling up in these areas?
Yeah, so I'll unpack that a little bit just to kind of start with what I think's going well. I definitely think the messaging is going very well. I mean, when you walk around the show, everyone's talking about digital engineering. I think everyone's aligned and sees the benefit that's been involved with it, like we have for some time. The requirements, the expectation that is part of the acquisition requirements, it's very clear. I think that's all gone well. And we're a supplier, so we don't see all of the interaction at the prime customer level. But I would say I've also seen a real willingness to enable large suppliers like Spirit to actually develop the connectivity and the networks and the being a part of those integrated digital environments. So a willingness to enable that. In terms of focus areas or maybe areas to improve on, probably try to answer those two together. Not necessarily something that we're doing poorly at, but on the supply chain side, usually suppliers are the folks that you depend on to pull through technologies and drive them into production and industrialize those and design those products. I think with digital engineering, there's an opportunity to pull supply chain in with prime partners into that earlier in the development cycle, with even at the lab level. So I think there's an ability for everyone to get involved further upstream in the process. And then supply chain-wise, other things to focus on going forward. On the commercial side, we're getting a lot more adept across. I've seen this at multiple companies at managing the supply chain digitally and managing our factories digitally. Even at Spirit, we've introduced a concept to our 737 production floor, and it's spread all the way across the production floor, called real-time asset tracking. So using things like RFID tags to track where every part is to make sure you don't have extra WIP, and then connecting that to dynamic scheduling so we're never working on the wrong part at the wrong time. And there's probably challenges, and I know there's challenges with taking RFID tags and gated processes into classified environments and being able to leverage that benefit. And I think there's a significant opportunity there to grow going forward. We've kicked off a project at Spirit, and it's not the first place I've heard of doing this, but we call it Supply Chain Control Tower, where the suppliers can actually look into, be connected to our system and see real-time demand and reorder points in the future, and also giving us the ability to peer down into the supply chain to see where our parts are at a certain point in time, and not have to depend on someone just entering in a database saying, yeah, your part's going to be there on time, but actually be able to actually see in their system when the raw material made it on dock and when it was loaded on a machine. And to have that kind of visibility is really powerful for someone like Spirit, who's redesigning our whole production systems around digital to get the cost benefit, and TAC-based flows that don't have a lot of WIP and a lot of room for parts just not to show up. We need parts on time to deliver the full benefit that this can offer. So that, to us, that's a big area of focus in helping enable that going forward. I think the last part of the question was about cost.
Cost, yeah.
We've ran very similar programs. Wallace talked a little bit about visual work instructions. To that, at Spirit, we have actually taken visual work instructions to some of our product lines. I think the KC-46 tanker integration is one of the first places that we actually implemented it in terms of having iPads with portable digital visual work instructions. In our future factories, we're going more to things like projected work instructions, still iPads, but also pick-to-light type systems. And in order to maintain that, we've done lots of pilots and implementations and spot implementations in production lines over the past. And it's just not affordable that whenever time you get a production change, to drive that through planning manually, to drive that through authoring of work instruction manually, and then for someone to drive that to machine that projects those work instructions. That's something that the affordability of maintaining that in the past has always been a barrier. So we've invested heavily in automating all of those handoffs. So you can use, when you define your digital engineering correctly, using the right seed models and the right approach, that can all be automated to where when you execute a change, you can actually drive visual work instructions all the way down to the shop floor without having to incur the cost of copying the data, handing it off to a planner, handing it off to a process planner down the line. So that's one place we've seen 50% plus gains in cost in the case studies that we've done initially. And then some of the other places from a cost standpoint are things like driving full-size hole assembly and drilling holes to detail parts and taking work off of critical paths. So when you bring it together as an end product, you have something that has much lower tooling requirements, so you're saving on tooling cost, but then your assembly labor is much lower, and overall the savings are much lower for the customer. And that also enables you to react to change a lot more quickly because you don't have such a tooling-intensive assembly process. So those are the key areas we see costs. And then I think Renee said when you bring it all together on new products, you get the full benefit of all of these pieces that we've been working across our product lines in one place, which is, I think, really powerful in terms of where we're going and our ability to scale that quickly for the customer.
Excellent. Thanks, Eric. Renee, so I want to get you to think a little bit about technology. And technology is always expanding, and you know, it follows the back of Moore's law. So we have these exponential increases of technology. And at the same time, it spreads globally faster than ever. So I want to get your thoughts on how do we maintain our advantage in that for the Department of Defense and for your company in this environment of rapid expansion and rapid global transfer of technology. Have any ideas there?
So I mean, the short answer is by going faster. And so I think part of what becomes really key is, as both Wallace and Eric talked about, is that ability to be responsive to change. Whether that is on something as, you know, in the DevOps world of making sure that, you know, you have everything you need to run your pipelines so that new capabilities can be automatically developed, deployed, and tested, or in the even building things out of metal and composites. The example they both gave of advanced work instructions, and to Eric's point, being able to in a machine-to-machine fashion, if you will, really drive, you know, an engineering change down to a production floor very, very rapidly. What becomes really important is when you say things like that and then you put on your production ops hat, right? The last thing you want is continuous change without forethought. And so that's where then being sure that you're aligned and that there is quality baked in and all of those other functions to make sure that what is getting there is what you want. But it's really that ability to be responsive to change and to be able to incorporate those new technologies quickly. And part of that comes back to, you know, digital engineering, open architecture in the broad sense, not just for computers, but also the architecture of how we architect the data for how we build and how we sustain. So that you really have that open environment with the right ability to also innovate. Because I think one of the key things in terms of being able to, you know, change and adapt quickly and maintain that leading edge is ensuring that there's room for innovation. You can't have your, you know, data flow be so regimented that there's no opportunity to bring new capabilities. If someone has a new idea or a new technology, most new technology is disruptive, almost by nature. Most processes don't like to be disrupted. And so how do you balance those two things and make sure that as, you know, particularly in the defense domain space, as one of the strengths, I think, from a national perspective is the innovation in industry, whether at large primes or small companies and everything in between, and making sure that you can integrate those things and that there's opportunities to do so. And that becomes, I think, a lot of the discussions that have been happening and need to continue from a partnership perspective on, you know, reference architectures. Certainly standards like Open Mission System Standard, OMS, is a prime example of that done incredibly well. Making sure that there is enough commonality, to Wallace's point, in you know, how we define things so that you know where you can insert a new thing, but not so much commonality that, you know, a new thing that doesn't fit gets discarded, because I think that's how you end up losing your edge. Someone comes up with a bright idea, whether it's in an Air Force research lab, you know, someone's garage, or you know, an R&D department at a major company, and it doesn't quite fit our current paradigm. How do we make sure it can still get integrated? Because that is how we maintain that edge and continue to accelerate. It's what you see the adversary doing. It is what we need to do better and faster.
Yeah, thank you. And I'd like to follow up on that last point you made with all of the group. And really, I want to talk about science and technology. So the White House has defined advanced manufacturing as the rapid application of science and technology to the manufacturing process. So I'm curious, from all three of you, what do you see? How well are we doing with that science and technology, and then keeping up with our competitors? And how are we doing in transitioning that technology into the manufacturing process, as you mentioned? Anybody would like to talk to that?
So if I can start with an example. So as I mentioned, one of the things that Skunk Works does is the leading edge for all of Lockheed in the portfolio. The application of, for example, AR and some of the digital work instructions, things like that, Over the last few years, being able to see that go from a bright idea in someone's head, we've used things like laser projection on a lot of our existing production lines for a long time. Taking the learning from that, combining it with the latest commercial technology that, what used to take a room full of computers is now some goggles you put on your head. And then starting to apply that, whether it is on a production line and making it faster, easier for our mechanics to put the right things together. Using it for training, right? So starting to see the technology now expand so that we can train people before they ever touch, anything for real. And it's almost like you don't get to actually go on the line until you pass your training with a certain score, and it's actually because you've done things more or less for real. To bringing it all the way to the flight line and making it so that we're starting to see it get used for applications there. So you see that initial core of technology that, frankly, just even outside of defense has matured significantly over the last just even 5 years. And you're starting to see it get applied, not just in the area where maybe the initial need was identified, but also in other areas where once someone saw, hey, I see how this works, I see how this helps, now I can start to apply it to my problem space and have that happen quickly and not have to reinvent how we do things every time. One of the areas we're focusing on right now is, to Eric's point, making sure that when we see those applications, that there's an easy way to get the data from wherever it exists to the end point of use with the most machine-to-machine way possible, very similar in some ways to the discussions around JADO and getting the data where it needs to go, so that you can get advanced capabilities applied in a variety of areas, including manufacturing. Some of the improvements that have been made, whether on existing production line or some of the new facilities we're bringing online across the corporation, have been substantial. And those changes have happened very quickly. And we're seeing the significant cost and schedule benefits from that.
Thank you. Eric?
Well, yeah, I think all the technologies and the benefits that we're seeing in the shop floor, I've seen a lot more willingness to take a chance on something that maybe we haven't used in production forever, but people see the benefits, and they're seeing in industries outside of aerospace that benefit. And we have a new generation now where everyone's grown up with a screen in their hand, and we have the new technologies, and adopting new technologies is not that foreign in everyday life. And when you look at what the adversary is doing, you feel like they're really pushing forward with a lot of risk. They're taking a lot of risk to get a lot of iterations and drive development, and with a real, I would say, there's somewhat of an allowance to fail. Now, I don't know how exactly that works out in the end, but that you see more failures in the development process. And so I think there's somewhat of a willingness right now to take a little bit more risk. And this is from a supply chain standpoint, remember that. But I think we're willing to adopt that too going forward, and that's something that'll help drive technology forward when done in the right areas.
Yeah, I was just going to add, Joel, and I just want to amplify some of what Renee said. At the core of our ability to move fast and bring new technologies and add new capabilities is architecting. And if you look at what's happened in the commercial marketplace with like AWS, with what they have with the well architecting framework, or Azure, or many of the companies that are out there, there's an abstraction of having reference architectures that enable us to be able to understand what those changes are, that they don't completely ripple through the entire system. So when you look at like science and technology, in 6 years ago, many of our programs that we had within Raytheon working on new radar technologies, as moving hardware to software, or other new techniques or capabilities, the only way that we could really take something forward was a brand new system. But yet in many cases, the ability to take those technologies and understand how to apply them to existing systems is difficult because everything is sliced up and architected differently. So everything it's challenging. It's not just model-based systems, there's an art. The other thing is there's a data piece of this that I think is we're just beginning to see. We talk about things like digital twins or digital thread. The amount of data that is being created across that thread for those twins is enormous compared to what we've historically done. There's a lot of information that gets kind of tossed aside because we get it all packaged up and we move the data on to the next person in the flow. The understanding of how to leverage that and knowing what we're looking at and where to pull strings, I think across industry, whether it's a prime or a supplier or our government partners, those two pieces and really understanding what is it that we're building, how does that abstract across a family of systems or programs, and understanding the data side of that, that's where the gold is for our ability to move faster, leverage all of these technologies together, and be able to drive capability in faster than having to go recreate something new every time we have some new widget that comes around.
Excellent. We just have a couple of minutes left, but I'd like to kind of follow up on that thought of developing new understanding and the culture to do all that stuff and talk a little bit about the workforce. So if you heard General Raymond talk earlier this morning, he talked about the Guardian ideal and the new Guardian strategy to develop technically deep Guardians. That in the Space Force has a new vision for a digital force that includes digital acquisition, which includes the digital engineering and model-based systems engineering, but there's also digital operations and digital workforce components and digital headquarters components to that. So I guess the question to you all is, are you finding it difficult to either gain or develop a workforce that's able to speak this language of digital engineering? Do we have, are you able to find the folks that are already trained? Are you having to train them up? Just curious what your perspectives are.
I would our people know. Our challenge in many cases is trying to help them understand all the different languages that are coming at them. I mean, we've got 26 different open architecture standards across all of the different sensors that we build from different services and others, and trying to understand, well, where do I go to get help? Which one trumps this one? That's just one little piece. We believe in the people that we have. They are capable of doing it. There is a cultural piece of this. There is no doubt about it. That is learning and understanding, but enabling them to have much, much more, to be able to operate with more speed and more autonomy. But it's not easy, but being able to see across a bigger swath of the business and our customer sets than they've been able to see before is really, really opening up for us a lot more, a lot less friction than I think we ever expected.
Interesting.
I think for Spirit, the key for us has been finding a great pipeline that's local. For a place like Spirit, it's really hard to pull from the coast in the Midwest. But we have a great partner like Wichita State University and NIRE, where they're actually training their engineers and they're putting them to work on things that we're working on before they ever graduate. So we end up getting engineers out of school with a couple of years experience already. And that type of spool up time and that gain has been, I think, kind of is going to be going forward key to us growing and having a workforce that's already being trained on digital engineering and already knows what to expect when they get into industry.
So to me, one of the interesting things is most of the people we hire, sure, we have to train them on whatever latest iteration of the tool it is we are using. To the panel's point, there's a bunch of different open architectures, there's a bunch of different tools, all that type of stuff. In terms of the mindset and the cultural change, one of the things that you see that these technologies enable is a really, cross-functional type of approach to things. Understanding not just what you do, but also how what you do impacts others and how what those others do impact you, and kind of that mindset. And I would say that a lot of people, particularly when they first join industry, that is very much what they're hungry for. That is what they want. They want to understand how their work matters. They want to understand how it plays. And they really appreciate getting that insight. And then the whole point is, to empower them and really to ensure that oftentimes the people best positioned to make, day-to-day decisions are the ones doing the day-to-day work, especially when they're then informed by everything else that's happening. It is a cultural change in terms of how we kind of normally do things or how we have done things in the past. A lot of it, I think, to me, is not so much about training the new workforce, but it's really about what does it mean when you have a highly empowered, highly informed workforce that has the access to all of those, latest technologies, and they understand how what they do impacts others, and they might start making decisions that are different than the ones you would have made, but it's for the same end goal. What is the cultural change there, and how are we training our, executives, mid-level leaders, and others like that to be able to see the positives of that and to encourage their teams in that way and to not be, threatened by that kind of change. I think that's where you see a lot of the cultural change occurring, and that's where strong leadership, alignment to vision, and all of those things we talk about from a change management 101 perspective are very, very impactful. It certainly is important to make sure that we have good pipelines in terms of talent, to make sure people are trained on whatever the latest thing is that we're applying. But I would also, say that we should not lose sight of, for a lot of people, this level of change and this level of adoption of new technologies is how we've all grown up. Making sure that flows through an entire organization at all levels, I think, is really the biggest cultural change that we need to be prepared for.
Thank you. Yeah, I concur with all of that. Well, with that, we're out of time, and I'd like to thank all three of you for the great perspectives you provided, and this has been a great conversation. So thank you very much, and we'll now break for lunch in the exhibit hall. Please be back in your seats by 1:10 p.m. Thank you all.